Good morning, good afternoon, and good evening. Welcome back to Chapter 18. We're talking about the survey of life. One thing I want to mention, remember, what is the strategy that we're using to talk about the animals? The strategy that we're using, actually, what is the strategy we're using for all living things? We're talking about them from least complex to most complex. And we use that strategy, which is why we talked about bacteria first, and now we've made it to animals. This is the same strategy we're using as we're talking about the animals. We're talking about the least complicated ones, the sponges. And then the more complicated ones, the jellies. And as we go up, we're going to go increasing complication. So our next group of animals is roundworms. The roundworms still retain bilateral symmetry. About 25,000 species of roundworms. There's probably another 40,000 species of them. We're not going to talk about different classes of roundworms, and the reason why is because they all look alike. They all look like little white worms. Lots of them are parasites. Not all of them are parasites, but lots of them are. They do possess bilateral symmetry like our last group, the platyhelminthians do. They've got three tissue layers. They've got a cuticle, a non-living skin that goes around the outside of the animal that must be shed for the animal to grow. Those three tissue layers, they've got endoderm, exoderm, and mesoderm. They've got inside, middle, and outside tissues. They use what's called a hydrostatic skeleton. So a hydrostatic skeleton is it's a skeleton that uses water. They compress water, and because water doesn't compress, they push against water-filled chambers, and that allows them to move back and forth. Our skeleton, we use bone that we push and pull against. Roundworms use water to push and pull against water-filled chambers. Unlike our last two groups of organisms, these actually have a complete digestive system. We talked about this with the platyhelminthians, and the fact is the platyhelminthians have an incomplete digestive system. These guys have a complete digestive system. They have a mouth and an anus, a way in and a way out. So, I forgot to put it on my board. This is Phylum, new group, nematoda. There are classes of flatworms, but we're not going to talk about the classes of flatworms. Phylum, nematoda. These are the roundworms. Here we can see the mouth. They actually have what's called a terminal anus, which means the end is the anus. It's right there. And see this wrinkled skin? That is that non-living cuticle that we were just talking about. This is a roundworm. Our next group is Phylum Mollusca. Mollusks, again, what domain are we in? Domain Eukarya. What kingdom are we in? Kingdom Animalia. Our next phylum is Phylum Mollusca. Phylum Mollusca, the mollusks. 100,000 species of mollusks. So many species, lots and lots of species of mollusks. Phylum Mollusca, they've got a muscular foot for locomotion. We'll show those in just a minute, but your image for a mollusk at the moment is just imagine a snail. A snail is a mollusk. That whole bottom kind of loaf of bread looking thing coming out from underneath of them, that is that muscular foot. You may have seen a clam or an oyster using that weird tongue thing to dig. It's not a tongue, that's their foot. They have a visceral mass. The visceral mass is for what contains all of their guts. We'll talk more about that visceral mass once we move on to the different organ systems in animals. Mollusks specifically have a structure known as a mantle. The mantle is what secretes the shell. Snails have shells. It's secreted by the mantle. Clams and oysters have a shell. It's secreted by the mantle. It is a special piece of tissue, a special layer of tissue that makes the shell. I'll show you in just a second. Most mollusks have what's called an open circulatory system. So now finally we actually get up to a group of organisms that have a circulatory system, that have a heart. Most mollusks have an open circulatory system. Your circulatory system is called a closed circulatory system. What that means is your blood stays in your arteries and veins. It doesn't just come out and just kind of wash around your guts. It is kept inside of your arteries and veins, and that is not the case. That's not how it works for lots of mollusks. Lots of mollusks have an open circulatory system, but this is the first group to have an actual circulatory system. Kind of a big deal to have this thing called a heart. The first organisms to have this thing called a heart. Most of them have a radula. A radula is like a tongue with teeth on it. I got a picture. Let's look at this picture. So here is kind of just a stereotypical mollusk. The visceral mass is this entire center section. It's just all of the guts inside of the animal. This is that shell. And underneath of the shell, just imagine kind of like a cross between a clam and a snail. Underneath of the shell is this tissue right here, which is called the mantle. And it is the job of the mantle to make. It is the job of the mantle to secrete the shell. Within the mantle is the mantle cavity, and the mantle cavity is where all of the guts are held. And there's all these various guts. They do have a mouth. Here's the mouth in the center. And this structure right there is called the radula. This is a blow-up of the radula, and you can see how it kind of looks a little bit like a tongue. And the tongue has teeth on it for scraping up food. If you've ever had like an aquarium with an aquarium snail, and this snail, you can see its little tongue come out, and it scrapes the glass clean. And so wherever these snails live, they use the radula to scrape up food. I do want you to notice, do you see this little yellow ring right here, and then these two nerve cords coming off? This is the brain. This yellow ring is the entire brain of the mollusk. It's the whole brain for the animal, a ring. And then, similar to the platyhelminthians we looked at just a little bit ago, it's got twin nerve cords. Twin nerve cords that go down that foot. See the foot here? All right? That foot is where the nerve cords go. And if we imagine then this is the animal, it would be moving like this, right, head first. Then this is going to be its belly. And so this is sometimes referred to as ventral. Ventral means belly. Ventral nerve cord. I do want you to note this structure right here, this is the gill. Obviously this is for breathing, but do also see the structure right here. It's the anus. What are they doing? They're pooping all over their gills. If I was going to build an animal, I would not do it that way. But I didn't build mollusks, and so they poop over their gills. On the positive side, some animals have gone through, some mollusks have gone through a process called torsion. Torsion means they have twisted, and they twist so that the anus no longer sits over the gills. That's great. They're no longer pooping over their gills. Instead, the anus comes out right here over their head. And now they're pooping on their head. This is an upgrade, people.